Okay, I think I explained this example before, but let me just point out a few things that I left hanging in here. We have solved this problem, the limit as x approaches infinity of this rational function. The idea is that you have to get the highest power from the denominator. In this case will be x squared. So I'm going to divide by x squared the numerator and the denominator as well. With the result right here, we have 3 minus 1 over x minus 2 over x squared over 5 plus 4 over x plus 1 over x squared. So the idea is that to get a feeling of how the function behaves as x grows very, very large. From theorem 5, we know that the limit as x approaches infinity of 1 over x, this is 0. And if I have 1 over x squared, this is also 0. And if I have 1 over x to any number, that is always 0 for any number that is positive. And this is true. So I could say that the limit as x approaches infinity, this will be 0, this will be 0, this will be 0, this will be 0. Therefore, the answer here is 3/5. Notice how I dropped the word limit because I already found it. The answer is 3/5. So the question to you here is, what happens as x approaches negative infinity of the same function? How would I treat this? And the answer is the same. X is growing very, very large, and as theorem 5 says, the limit as x approaches negative infinity of 1 over x, this is also 0. And if I have 1 over x squared, it's also 0. And if I have 1 over x to any number, this is also 0, as long as x to that number has a domain of all real numbers. And if this is not the case, then I cannot say it's 0. But luckily for us, all these powers in here have domain all real numbers, so I could say that this is again 3/5 as well. Let me show you on the graph. This is something that I would like to show you. I input in y1 my function, and I'm gonna graph it. So by looking at the graph, it may seem that the limit as x approaches infinity is 0 because it looks like it's getting closer and closer to the x-axis, but that's not true. If I go to table and I'm giving values of x that are very, very large, I can see that this decimal, let me have another one, delta table 100. So my table is going to go up by hundreds. So this decimal, more and more, is going to reach 0.6, which is actually the fraction 3/5. So you can check it on the table that the limit is not going to be 0. The graph may be misleading in this situation, so please note everything that looks very close to the x-axis, its limit is 0 as x approaches infinity or negative infinity.